Good morning, all of you. Today, in this class, we will discuss a new topic, that is P block elements. In previous classes, we already discussed about S block elements. So, now let us discuss about P block elements. Okay. So, first of all, what is meant by P block elements? Why we called it as P block elements? P block elements means the elements in which last electron enters in the outermost p orbitals. P orbital. This is called P block elements. Okay. So next one, the number of p orbitals is 3. Okay. The number of p orbitals is 3. One is px, py, pz. Okay, the number of p orbitals is 3 and the maximum number of electrons can be accommodated in a p orbital is 6. Maximum electrons in p orbitals is 6. Okay, 6 electrons can accommodate in p orbital. Okay. So next one, the elements belonging to groups 13 to 18 of the periodic table are called P block elements. So P block elements contain total 6 groups. Okay, one is 13th A group elements, 14th, 15th, 16th, 17th, 18th. Okay, so 13th A group elements contain boron, aluminium, gallium, indium, thallium. Okay, 14th A group elements contain carbon, silicon, germanium, tin, lead. 15th A group elements contain nitrogen, phosphorus, arsenic, antimony, bismuth. 16th A group elements contain oxygen, sulfur, selenium, tellurium, polonium. 17th A group elements contain fluorine, chlorine, bromine, iodine, astatine. 18th A group elements helium, neon, argon, krypton, xenon, radon. Okay, these elements are P block elements. Okay, so next one, general electron configuration of P block elements. General electronic configuration is ns2 np 1 to 6 except helium. Okay, so ns2 np 1 to 6. 1 to 6 means here 13th A group elements having ns2 np1. 14th A group elements having ns2 np2. 15th A group elements having ns2 np3. 16th A group elements electron configuration is ns2 np4. 17th A group elements ns2 np5. 18th A group elements ns2 np6. So here, except helium, the general electron configuration of p block elements is ns2 np1 to 6. Although helium does not have p orbitals, it is p block element because the properties of helium is same to the 18th group elements. The properties of helium resemble to 14th group elements, these elements. That's why helium is considered as p block elements. Okay. So in p orbital maximum electrons is 6. That's why here 6 groups are there. Okay, next one. So the p block elements outermost electronic configuration is same in all groups. P block elements outer electronic configuration is same in all groups. But inner electronic configuration or core electronic configuration is different. P block elements outer electron configuration is same in all groups, but inner or core electron configuration is different. So therefore, based on different inner electronic configuration, the properties of p block elements is different. The properties of p block elements is different, such as atomic or ionic radius, ionization enthalpy, etc., as well as chemical properties, Okay. Based on different inner electron configuration, the properties of p block elements is different, such as atomic or ionic radii, ionization enthalpy, etc., as well as chemical properties. Okay. So next one, oxidation states. Okay. The maximum oxidation state shown by p block elements is equal to the total number of valence electrons, that is sum of the s and p electrons, that is sum of the s and p electrons. Okay, so that means clearly the number of possible oxidation states increases towards the right of the periodic table. Okay, so in periods left to right, the number of valence electrons increases. So definitely the maximum oxidation state of p block elements also increases from right to left in the period. Okay, in 13th group elements, the electron configuration, valence electron configuration is ns2 np1. 14th group elements is ns2 np2, ns2 np2. 15th group ns2 np3. 16th ns2 np4, ns2 np5, next ns2 np6. Okay, this is the valence electron configurations of 13th to 18th group. So next one, first member of the group in 13th period is boron, 14th period carbon, 15th nitrogen, 16th oxygen, 17th fluorine, 18th helium. Okay, helium electron configuration is 1s2 here except helium. Okay, so next one, 13th group elements, the maximum oxidation number is 3 because total number of valence electrons is 3. So next one, 14th group elements 4, 15th 5, 16th group elements 6, 17th group elements 7, 18th group elements 8. Okay, so next one, these p block elements also show other oxidation numbers, also exhibit other oxidation numbers. Okay, here 13th group elements shows +1, 14th group elements +2, +4, and 15th group elements exhibit +3, -3. 16th group elements exhibit +4, +2, -2. 17th group elements exhibit +5, +3, +1, -1. 18th group elements exhibit +6, +4, +2. Okay, this is the other oxidation states. Okay, so next one, p block consists metals, non-metals and metalloids. P block consist metals, metalloids and non-metals. Okay, the non-metallic character of elements decreases down the group. That means definitely metallic character increases down the group. The non-metallic character of elements decreases down the group. Definitely metallic character increases. Definitely metallic character increases. In fact, the heaviest or last element in each p block group is the most metallic in nature. Okay. So therefore, the heaviest or last element in each p block group is the most metallic in nature. Most metallic in nature. Okay. So next one, in general, due to small size, non-metals have high ionization enthalpy and electronegativity. Non-metals generally small in size, so these non-metals having high ionization enthalpy and electronegativities. Due to small size, in general, non-metals have high ionization enthalpy and electronegativity than metals. Generally, non-metals is small in size, so these non-metals having high ionization enthalpy and high electronegativity than metals. So therefore, metals readily form cations, and non-metals readily form anions. So next one, the compounds formed by highly reactive non-metal. The compounds formed by highly reactive non-metals with highly reactive metal. Are generally ionic in nature. Because of large difference in their electronegativity. Okay, this is the reason for formation of ionic compounds from non-metals with metals. So next one, the compounds formed between non-metals with non-metals, they can form covalent compounds. Compounds formed between non-metals with non-metals generally the compounds formed between non-metals with non-metals are generally covalent in nature. Why? Because of small electronegativity difference. Okay, small electronegativity difference. So next one, non-metal oxides are acidic or neutral. Non-metal oxides are acidic or neutral, whereas metal oxides are basic. Okay, so next one, The first member of each group differ from remaining members of corresponding group. The first member of each group differ from remaining members of corresponding group. Why first member of each group differ from remaining members of corresponding group? That means due to small size, high ionization enthalpy, high electronegativity and no vacant d orbitals. Okay, first member of each group differ from remaining members of corresponding groups because due to small size, high ionization enthalpy, high electronegativity and no vacant d orbitals. Okay, first member of each group is small in size, having high ionization enthalpy and electronegativity and no vacant d orbitals. That's why first member of each group differ from remaining members of corresponding groups. Okay, so first difference is first member of each group belongs to which period? Second period elements and have only 4 valency electrons and have only 4 valence orbitals, that is 2s and 2p orbitals. In 2s 1 orbital is present, in 2p 3 orbitals is present, total 4 valence orbitals. Okay, they do not have vacant d orbitals. They do not have vacant d orbitals in their valency shell. So therefore each member has minimum covalency or valency of 4. Therefore each member has maximum covalence or valency simply of 4. Okay, each member have maximum covalency of 4 using which orbitals? 1 2s orbital, 3 2p orbitals, total 4 covalency. Okay, so next members belongs to third period. Okay, here in this p block elements, here this is a second period elements. Boron, carbon, nitrogen, oxygen, fluorine, neon is a third period elements. Helium is first period and aluminum is third period element. Okay, so next members belongs to third period. Next members belonging to third period are also called higher periods. Okay, the next member belonging to third period or higher period have vacant d orbitals. For example, third period of p block with the electron configuration is 3s to 3p n. N means n equal to 1 to 6. Okay, so the electron configuration is 3s to 3p n, as it has vacant 3d orbitals. These 3d orbitals lying between 3p and 4s as vacant d orbitals. That vacant d orbitals lying between 3p and 4s energy level. For example, here I am taking aluminum. Aluminum atomic number is 13. Electron configuration 1s2, 2s2, 2p6, 3s2, 3p0, 4s0. 3d0. Okay, so here empty d orbital is present. So in this aluminum, vacant d orbital is present. This d orbitals lying between 3p and 4s. Okay, so therefore they can easily expand their covalency above 4. So for example, here I am taking boron and aluminum. Boron forms only Bf4 minus. Okay, here boron valency is 4, or coordination number of boron is 4. Okay, next one, aluminum forms aluminum F taken 6. Here aluminum covalency is 6. Okay, so due to vacant d orbitals, heavier p block elements exhibit covalency more than 4, but second period p block element shown covalency is 4, up to 4. Okay, next one, tendency to form multiple bonds. Okay, due to small size and availability of p orbitals, the first member of each group shows greater tendency to form p5 multiple bonds either with itself such as C double bond C, C triple bond C, N triple bond N, and O double bond O, or with other members of the second period of elements, such as C double bond C, C triple bond N, N double bond O, etc. Okay, so the first member of each group shows greater tendency to form p5 multiple bonds either with itself or with other member of the second period elements. Okay, so next one, if you take heavier p block elements, heavier p block elements of the group do not have strong tendency to form this type of p5p5 bond, p5p5 bonding. The heavier elements do form 5 bonding, but they involve d orbitals and form d5d5 or d5p5 bonding. Okay, this is the differences. First member of each group from other corresponding members of group. This is a difference of each group from remaining members of corresponding group.